React makes it easy to build UIs, but building fast React apps is a different skill altogether. In this hands-on real-world React performance optimization crash course, you'll learn how React actually re-renders, why your app slows down, and which performance patterns truly matter in production. Not just theory, but battle-tested techniques used by senior engineers. This video is about knowing what to optimize, when to optimize, and how to do it right. Top has created this course.
Hey, hello everyone. How are you doing? Welcome back to Performance Patterns. Yes, it's plural patterns because we are going to talk about multiple patterns that can help you to optimize performance of your React.js app. What I have seen in my career coding with React.js extensively, that most of the performance concerns come from only one thing, that is re-rendering. When your React apps re-render, when state changes, when props value changes, when context value changes, if the parent component re-renders, isn't it? So in all these cases, the re-rendering may happen. So if we can control re-rendering, I think we'll be able to address most of the performance issues. After understanding a part of re-rendering in React, we are going to talk about the techniques that we're going to learn in this session. It's called Memoization, Derived State, Debounce, and Throttling. We're also going to look into splitting components, virtualization, context optimization, React compiler. These all are different techniques through which you can control performance degradation of your application. And each of these pointers will bring design patterns that you can adhere to make sure that the performance of your application is taken care. As you can see, there are a lot of things to be done. I thought of splitting this session into two, part 1 and part 2. As part of part 1, we are going to cover from memoization to debounce and throttling, and rest of the pieces will be taken into the part 2. So before we start talking about any techniques, it makes a lot of sense to look into re-rendering and take some examples. Here on your screen, you are seeing an application. This application is a combination of a parent component and a child component. This particular text box, what you see over here, is part of the parent component. And on top of that, you are seeing something called rendered colon 2 times. That is a child component. Now, any changes that I make in the parent component in state changes, of course, the parent component will re-render. That's how React works. We have spoken about it already. When the state changes, props changes, context value changes, or the parent component changes, the re-rendering happen. So it's out of React's own philosophy. If I change the state of the parent component, the child component also re-renders. This is how it happens. If I put a letter over here, a character over here like A, I am seeing this 2 jump to 4. If I type one more called V, it becomes 6. If I keep typing, it keep increasing. So it means for every change of the state of the parent component, the child component is re-rendering. Now you might be asking question that, okay, fine, it is re-rendering, but why the value is going double? Why it is not single? It is because React runs something called a strict mode. That's why the re-rendering happens twice. Okay, this has happened only on dev mode if the strict mode is on. If the same code is running on the production mode, this is not going to happen. Now this is the parent component, which is called render tracker demo. So what is this component doing? As I told, it has an input box. This is the input box. And it has a state called value. What is happening whenever there is a change happening in the input box? I'm typing certain character. I am just changing this value using the setValue updater function that I get from the useState. We all know that. That means I'm changing the state of this particular component. Now, this component also has a child component, which is called render tracker. We'll go there in a moment. Now, whenever a state value changes of this parent component, React forces the child component to re-render. That is why we were seeing the re-rendering count. You don't see the re-rendering count anywhere in the parent component because the re-rendering count is kept in the child component. Let's go to the child component. Now over here, you are seeing this re-rendering count. It is happening. Renders.current, what I am showing. This is a simple React component, act as a child component over here, which keeps tracks of how many times it gets rendered. Now, if you have seen the previous session, I clearly called out the difference between useState and useRef. useState, with every render, the value will be flushed out, cleared, reinitialized. But for useRef, in every render, the value will be retained. And also changes of the useRef value doesn't force for a re-render, whereas the changes of the state value force for a re-render, right? We have learned all these different nitty-gritties. Now here I have used the use rep because I wanted to preserve the value of rendering across multiple renders. And this is the same exact value what I'm increasing, I am displaying also. So it means that if my parent component re-renders due to this state change value over here, it is forcing the child component also to re-render, and I am able to see this over here. That's exactly we are seeing over here. So this is just to show you, just to set the ground that what re-rendering means. And sometimes re-rendering this child component because parent component is re-rendering might cause a lot of trouble. So all the techniques that we'll be talking about today in the part 1 are going to take care this kind of re-rendering which may not be required. How can we stop them in a optimal way? The first technique is memoization. What does it mean, memoization? It's basically a computer programming optimization technique, I would say, which to speed up your program by storing the result of a function's execution and then use the stored result, the cached result, if the input to the function doesn't change. So if we take a function, say fx, where x is the input and it produces a result, say y, and now we can cache this particular result, and anytime someone call this function, we will always return the same result as long as the input provided to the function remains same. This particular technique is called memoization technique. So it's a caching technique where you can cache the output value of a function and always return the same value as long as the input to the function remains same. If the input to the function changes, for example, from x, if it become p, of course, it may not going to return y again, right? It's probably going to return z. In that case, memoization technique won't be returning the old y value. Rather, it is going to cache the z value and going to return the z value again. This is how the memoization technique works. Now in React, there are 3 different ways we can do memoization technique. First, using a function called memo that's provided by React. Second, React provide a hook called useCallback. Using that, we can apply memoization technique on our React components. And the last one is called a hook called useMemo. Using that also, we can achieve the memoization on our React component and the React application. However, each of these techniques has got their own benefit and the disadvantages. We are going to talk about each of this technique, going to show some examples. However, in the modern React, there is something called React Compiler, which we're going to cover in the part 2. And I've already created a video on React Compiler extensively when it got released initially. But I'm going to talk about React Compiler in the context of the latest version of React in the part 2, where we'll be talking about how some of this memoization technique like memo, useCallback, useMemo, you should be looking at if you are building a React application from the scratch today versus a React application that is already there as a legacy code with you. But that's part 2. Now in part 1, let's take a look into each of this technique one by one. First memo, then useCallback, and then the useMemo. Take a look into this application, almost similar to the one that we have seen before, that whenever this application got rendered first time, it logged something called rendered profile card. It means that I have a component called profile card and it rendered profile card. Now let me tell you, profile card is a child component over here, which is showing the profile information. Now in the parent component, like before, I have a text box over here, and look at what happens when I type a key over here. I'm typing A. The moment I type A, the profile card got the log for rendering profile card came here. However, this rendered profile card is there only in the child component. It is not there in the parent component. So it means like before, as we have seen, once the parent component is re-rendering, it is forcing the child component also to re-render. Now I keep typing character. If you see in my right side console, it's going to keep logging. It's again logging twice. I have given this explanation before. And in fact, you can see in the debugging tool, the one coming because of the strict mode is in much more muted color. Now let us take a look into the code. This is the parent component. Again, like before, I have an input box. I have a state called value and I am changing the value of it on every key type. And there is a child component called profile card. Whatsoever, this profile card is never ever related to this value. I am not passing this value as a props at all. I am passing a hard-coded name called tapas. That means this profile card is not changing because it has a dynamic prop value. It is changing because its parent's state value I am changing here using the on change you see over here. That's the reason by React's philosophy, the child component is re-rendering. Now, if I go inside this child component, it's a very simple component, takes the prop and it just says that render the profile card and showing that particular hard-coded prop. Now, if I think that I have a child component and that child component I should not render at any cost until unless the input to the component changes, I can use the technique of memoization. And the first technique, as I told, is using the higher order function that React provides called memo. So the first thing that we'll be doing is to import the higher order function called memo from React. So I've imported memo from React, and then you have to encapsulate this entire React component function inside this memo function. You know what higher order function is? If you have followed my 40 days of JavaScript, I have clarified all these concepts very clearly. A function that takes another function as an argument or can return a function from itself is called a higher order function. So memo is a higher order function because now you can do something like this. You can use this memo and then you can pass this entire component function that we had to get a completely new memoized function. Now this memoized function is your memoized component. So instead of exporting the profile card, which you were doing before, let us just export the memoized card. Simple enough. So this is what you need to do. That much alone is enough. So you have imported the memo higher order function. As it is a higher order function, it can take another function as an argument. You have passed your component function, got a memoized function, and you are exporting from here. Coming to your parent component, there is no changes required. If you just want, you can probably this name as a memoized card because you are doing an export default. You can import with any name. It makes sense to do it as memoized card because you can then recognize it's something that you have memoized intentionally. Now the behavior will change. Here, first time when it got rendered profile card. Great. Now I'm going to press one character. That's going to change the state value of my parent component. But this is never ever going to change anything for my child component because child component is taking a hard-coded props, right? So first value, if I am pressing, nothing happens. My child component is not re-rendering because I am not getting re-render profile card again. I'll type more characters. I'm keep typing characters. You see here, my child component is not re-rendering. It is because the memoization is done over here and the child component is taking a hard-coded value over here. Like, so until unless this value gets changed, this props gets changed, the child component is never ever going to re-render even when the parents component state value is changing over here. So this is the first step. Now let us understand the next tool that we have is called useCallback for this memoization pattern. Now I didn't show you the application. Rather, let us start with the code because just now we have learned about this memo, isn't it? The memoization. So see, this code should be familiar to you. I have a component called child, and this child component is a very simple component which takes a props and then console.log says the child rendered and return a simple button. The button has a on click and click on it what function to call, that is what get passed as a prop. So this is a very simple React component. But the twist over here is that this particular React component is passed to the higher order function called memo so that we get a memoized version of it, and this is what we have exported from here. Cool, very simple memoized thing. Now let's go to the parent component. We have imported the child. Just like before, parent component has its own state called count. It got its own button called increment. The moment I click on this button, the value of the count goes up by 1 using the set count updater function. So on click, I am calling this set count plus 1. It means this count value will be increased by 1. It means I'm changing the state of my parent component. I have also used the child component over here, and as I have explained, the child component takes a on click props, which is over here. I pass the function that should be executed when somebody click on a button which is inside the child component. Now, what do you think is going to happen if the parents component state count gets changed? So far, we have learned that using memoization, if the child component can be passed through the memo higher order function until unless the input gets changed, my child component is never going to re-rendered even if the parents component state gets changed, parent components re-rendered because of any reason. So in this case, Anto is satisfying two cases. One, the child component is already memoized, and the props of the child component, the props value of the child component is quite static. It is never going to change. So it means that if the parent component state changes because of this button click, the child component should never get re-rendered I should not see this console.log child re-render when I am clicking on this increment button. This is what my expectation. Now let's go and look into the application. So first time, of course, app rendered, child rendered. That's great because first time it has to render. Now I'm going to click on this increment. Look at here what happens. I click on increment. Oh my God. It again printed app render, child render. I click over here, app render, child render. Oh my God. So that means when parents component state is getting changed, child component is also getting re-rendered even when I have used the memoization technique. Why is it so? So here basic JavaScript come into picture, guys. No React, nothing. React Memo is fantastic. It re-render your component only when the prop changes. However, when comes inline functions like this, though it looks like it's a static function I am passing to onClick. Now, the beautiful part of function is just like an object in JavaScript, it's of reference type. So on every render, a new reference of this function will be created. So if a new reference of this function gets created on every render, it means the onClick value on every render of this component is new, isn't it? First time when my parent component got rendered, this particular function's reference value was, let's say, x. Now when I click on this button to change the count value, that is the state of my parent component will get re-rendered. The moment the parent component get re-rendered, this particular line, this particular value will get a completely new function which is having a new reference in the memory, though it may look exactly same with the previous version of it. As it's a new reference, completely new function, it means the prop value had got changed. So of course, the child is going to get re-rendered even when the memoization has been applied. So this is what you need to really observe closely. Inline arrow functions break memoization because they create new identity every render. This is the thumb rule. This is the mental model that you need to keep it. Now to fix this, React gives us something called useCallback. That's a inbuilt hook that React gives us, which helps by stabilizing the function references. So it means that when I use callback hook is never ever going to look into only the shape of this particular function. Rather, it is going to look into the reference of it. So far whatever happened is like inline function, every render, new reference got created means props value changed, my memo breaks and my child component got re-rendered. But with useCallback, it will ensure that react.memo will see always the same object. Can you change the code? Yes. Now to change the code, it's pretty simple. Let us take this one, the onClick one, into a function called handleClick. And over here, let us import useCallback and define const handleClick equals to useCallback, which takes a callback function inside which you have to write what you want to do. Let's say I write console.logof say clicked, and then you have to pass something called a dependency array. So this dependency array is similar to what we have seen in useEffect earlier, right? If you don't pass anything, it is just once. But if you can pass any dependencies, whenever the dependency changes, only then you explicitly tell that even if the memoization applied on the child, I want to re-render the child. But unless my dependencies are not changing, their value is not changing, useCallback would ensure that even if you have a memoization over here, will ensure that your child component doesn't get re-rendered, right? So that's the difference. So with this, can we run this app? First time, app rendered, parent rendered, child rendered. Now let me click on increment. Only app rendered. I don't see child rendered anymore. Only app rendered. Only parent rendered. Now if I click on a button that is there in the child, I'll only see the child rendered. So click, child clicked, only child rendered. If I click on the parent one, only parent rendered. You see this? Now my memoization technique is working really well. So what are the things happened over here? When I click on increment, my parent component renders. But the handle click function over here doesn't get recreated because handle click is now very much memoized using useCallback. Child receives the same function, this handle click function, always on every re-rendering of the parent. As the handle click is not been recreated, it always pass the same reference. That means the value of onClick remain intact, just like before. And then child doesn't get re-rendered. Now imagine if there is a dependency value that I am passing to useCallback, and if the dependency value changes, only then this handle click will have a new reference, and that reference value goes over here. That means the props value of child changes. Now child gets re-rendered. This is exactly, guys, use callback does. Now many people just use the syntax, but they may not understand the depth of it, like how it works. I tried my best to give that to you. I hope it makes sense to you. And I want to know, like, how is this 15 days of React design pattern going, guys? If you are taking this course, I'm putting a lot of effort. Believe me, lot of effort. I would love if you can share a few words about it in the public. If you can tell people like something like this exists, so that more developer who really wants to learn and want to grow senior, not in terms of years and the age, but by experience of handling React project, for them this will be immensely useful. And making something out for free, I feel really proud to giving back to the dev community. And if dev community also can help me to spread the word about it, that will be really great thing. Thank you, guys. So let's move on to the next one, which is useMemo. All right, coming back to the useMemo. So here is a simple demo. Okay, don't look into this name too much. I have used the same name. You can use any random names, for your demo. So what is happening basically? Again, the parent-child relationship in the components and all. So the parent component is having this number and the increment, just like before, a count. So if I click on this number gets incremented. That's it. And the child component has a sorted array and listed each of the name from the sorted array. Right now I have listed about 1,000. You can make it like 10,000, 100,000, 1,000,000, whatever it is. Consider it's a big array. Inside that array, you are performing sorting mechanism or sorting algorithm. Now what happened? Due to our parent-child relationship and how React works, we know that if the state value, which is the 0 of the parent component changes, it is going to force this child component also gets re-rendered. Over here, if you see on the first render, user component re-render, it is coming from this particular sorting thing. This is the user component. Now, if I click on the increment once more, I can see the user component re-rendered happen once more. If I click again, if I click again, if I click again, every time I click, it is going to happen. Coming back to the code, this is my parent component where I have that button, increment button. And as you have guessed, there is a count state. Clicking on that increment button, I am setting the count by incrementing his value by 1. That's it. That's all I'm doing. Now I also have this child component where I'm listing all that usernames, and the usernames are coming from a method called say get user that I have written in my utils. It is there. It can return 10,000, 100,000 usernames. Okay, and this users is what I'm passing as a prop to my users component, which is a child component. If I go to the users component, it takes this prop, it put this console.log. That's what we have seen, user component re-rendered whenever the count gets incremented. But here I am doing an operation, I am sorting it, and then the sorted user I am putting over here. Simple component, but there are a lot of problem in the line number 4. The first problem is I am sorting this array, which is a huge list of user object, for example. Now if it has a 100,000 user object, this is going to make this sort every time this component gets re-rendered. So that's the first problem. Second problem, I am actually mutating the original list of user, right? Which may create certain issue because ideally I should be creating a copy of it and then only do the sorting. As I am sorting the large data and this is just getting re-rendered on every button click or say every key down, it takes a lot of time to process this sorting, right? So that slow down my UI. And we all know if the parent re-renders, child re-renders, so sorting happens every time. Now, this is not a great use of my energy and time to have this kind of sort going. Though we have taken the example with sorting, but there are other such functions like filtering, running any kind of expensive computation, formatting heavy data, doing object or array transformation that produce new functions, new objects, new references, all are going to create similar kind of problem. And that's exactly where useMemo comes in. useMemo helps you to cache the computed value until its dependencies change. Use callback, we have learned that what it caches the references until the dependency changes. We have seen it with function. useMemo cache the value until its dependency changes. Imagine useMemo as something which memoize the return value of the function. and it cache it. It always return you the same value if the input remains same. If the input changes, it is going to return you the change value and again cache that value, so that from next time it can again return you the cached value if the input doesn't change. Now the same code we can change with useMemo pretty well and pretty easily. For that purpose, first thing first, import useMemo from React. Let me comment out this sorted thing and let me write the logic for sorted using useMemo. So I'll have useMemo. This again take a callback function, and just like use callback, you can pass a bunch of dependencies over here. Instead of mutating this list directly how I was doing before, let me first create a copy of that list using the spread operator, and on top of that I can do this sorting logic. So I'll be just copy pasting this one, and this is going to return me new sorted array. That's I'm going to return, and as and when the list changes, I am ready to do this computation. If the list doesn't change, I am not ready to do this computation. So you understood, use memo is a hook that takes a function and a dependency array. That dependency array decides when the input changes, then only whatever you have written inside this callback function has to execute, otherwise it won't. So what execution we are doing? If this list changes, then only it makes sense to sort it again. And then the return value will be over here, which we are already using to map it out, right? Isn't it? All right, now let's go to the UI and see what's happening. So first time, on the first render, it says the user component rendered. Great. Parent rendered and child also rendered. And it's sorting the expensive list. So first time the use memo got called because list, the value of list supplied for the first time to the child component, the user component. Now, if I increment, what happened? If I am incrementing, I am saying that user component rendered, this log I got. However, this sorting expensive list log has not come. That means if I keep incrementing, of course, my parent component state value changing. So why my child component is also getting re-rendered, because child component I have not memoized. Entire component I have not used in this case inside the memo higher order function. So it will definitely re-render. But even if it is re-rendering, the heavy computational logic, the sorting logic, that is not getting executed. See, I am incrementing. Only first time it came, sorting expensive list. But rest of the time, it is not coming. So if I go to the code again, this will be coming every time because this child component is getting re-rendering. That's fine. I'm completely fine with that. But this computation is not happening again because this list is quite static. That's what I have got from my utility function. If this list changes, only then it will be recalculated again, and only when you will see this console.log once again. So for any kind of such expensive operation, it's always good to use useMemo. Now again, the catch over here is please don't use useMemo for any smaller computations. It is not going to save you much. See, even to look into, like if some value is cached and then only return the cache value or return the new value, it requires certain computation within. React is computing something at the background, right? Now for a smaller calculation, like for 5,000, 10,000 values, why would you do that? If the value really grows, where your application performance, the search, the button click, adding to the cart, something is getting very much sluggish. Only in those cases, think about using it. Don't use it just because it is there. Sometime eagerly optimize the performance of your application may introduce more performance bottlenecks. So you have to be really careful where you should be using, where you should not be using. So I hope the memoization technique is quite clear to you. Now let us talk about the second technique. Can you sense what is wrong here in this code? So this is a simple cart component. What I'm doing basically, I'm taking the number of items that are there in the cart and then computing the total number of price that somebody has to pay, the total amount somebody has to pay to purchase the item there in the cart. And then I'm just rendering that total value over here. Very simple. I kept this use effect over here to calculate the total sum, the total amount that somebody has to pay. And that's how, after computing the amount, I'm just changing my state variable. And this is what is going to reflect over here. Is there a problem that you see in this code? If I run this code, it will beautifully run. If I just pass an array of items with their price, it is definitely going to run and give me the total rendered on the component. Then what is the problem? The problem here is with something called derived state. That's another thing that causes a lot of performance problem if we are not careful. What is a derived state? Derived state is any value that can be computed from existing state or props. Okay. Again, I'll repeat. A derived state is any value that can be computed from existing state or props. For example, you have a list, you can derive the filtered list from there. You have the cart items, you can derive the total amount for the cart. You have a text, you can derive the length of the text. You have a boolean, you can derive the enable disable states from that. Derived state should not be stored in another React state. This is a problem I have seen tons of time whenever I reviewed code in my life. Derived state, again, the rule, derived state should not be stored in React state. Why? Because storing it cause unnecessary re-renders, which is the cause of many problems in terms of performance of your React application. Secondly, if you are storing derived state as another React state, you have to synchronize between the original state versus the derived state. What if your original state becomes stale? Your derived state still out of sync. You have to do a lot of complex logic sometime to manage this synchronization, right? And always you are doubling down on the re-rendering whenever certain updates happening. Why do you want to do that? So that's exactly the problem over here. Now, if the same cart component I have to rewrite as a better cart, it will be much more simpler. See how it is. I'm getting the items from items using the JavaScript reduce method, which is the exactly same logic that I have used over here. I am now computing the total and then rendering the total. That's it. Whenever the props change, this value will change. Why I have to do another use effect? I have to manage another state, another derived value for this as a state and use it. Now there is no basically unnecessary things happening over here, right? I have reduced the load a lot. I have written very less number of code over here. So this is an anti-pattern, storing derived state in use state. What we have seen over here, please stay away from this. Now here is one more example. Tell me whether it's a good example or bad example. I have the users component. I am taking a list of users and then I am filtering this. Maybe this list contains 100,000 users. So of course I have used useMemo. By now you know why we used useMemo. It's a expensive time taking computation. So as long as the user list stays same, I don't want to filter them again and again. So it filter out only the active users using this user.active. These active users get returned and I'm using active users over here as a map. Is it a good practice? Bad practice. Now, first thing you need to answer. Am I using any derived state? No, because I have not declared anything with useState. And this particular guy, whatever I'm using in my JSX, is not a state. Because to make it as a state, either I have to use useState, useReducer, things like that. I'm not using. It's a simple variable that returns a heavily computed value. I'm using useMemo because I care for it, because my list may have 100,000, 1 million users. So active users now has heavily computed user value, and then filtered user value, active user value, and then I'm just rendering on my JSX. That's it, simple. So no derived state is a good way of doing things. However, this one, of course, this is wrong because I get an age, then again, like before, based on the age value, I am checking whether the age is greater than equals to 18 or not. In that case, the person is adult. So I have a Boolean value is adult, and based on that, I'm saying adult or minor. I don't need this computation inside use effect. I don't need this derived state. I get the age. I just have a variable called const is adult equals to age greater than equals to 18, and then use is adult directly over here in this condition. That's it. Correct? So no derived state, no drama, extra drama in your code. This is another one I have seen in terms of form. This is taking name and email. I have to validate it. Why would I create again a state called is valid? And again, why I use is effect unnecessarily? Whenever the name and email changes, I am marking as whether the is valid is true or false, and based on that, I'm taking a call. No, don't do that. Rather, create a variable called const is valid equals to this particular logic. So whenever name and email prop changes, that will be called, and then is valid, you use as it is. That's it. No derived state at all. So these are some of the practices I hope that you keep in mind. And I hope you understand why derived state is bad and how you can get rid of it as much as possible. Now let's go to the next technique. The next performance technique or the pattern that we're going to talk about is called debouncing. Now again, if you are someone who is following me and following 40 days of JavaScript, you know that I had a session on performance optimization of your JavaScript app, and there I have explained debouncing and throttling and concept like that visually, right? Now I'm going to explain it over here also, but let's see the problem first. Let's imagine this is a portal where I can search user, and this makes an asynchronous call on an API, fetch the data over the network and display the search result, the match result at the bottom. I have not implemented that entire stuff, but I've implemented it so far so that I can show you the demo. So here, as and when I type something like TAPAS, if I type on my every keystroke, you can see a console.log appearing over here, which is given at the place where I'm making the API call. So if I type TAPAS, if you see that, I made an API call with TAP. It means that for every keystroke, I have made an API call. Now, these API calls are not cheaper. They are costly. They are expensive. Why they are expensive? Because you have to make them over the network. And then some of the API calls may have rate limit. You probably have to pay for those API calls once you pass the threshold. So you got to be very sure that you are not going to call this API so rapidly. Rather, you need to have certain mechanism where you can actually control this. This is where debouncing come into picture. So what debouncing is? Debouncing is a technique through which you can delay the execution of a function by certain time. Okay. Now, one thing you have to remember over here, whenever I'm typing something on my input text box, I am actually triggering an event. That is what? On change event. Now, through debouncing, you are not controlling that event. You cannot control that event. The event will happen. The on change event will trigger. But due to the on change event triggering, you were calling certain function on the API. You can control that. Okay. Some folks, they get confused with, oh, debouncing means I don't trigger the event at all. No, event will be triggered, but due to that event trigger, there is to be a function call. That function call will not happen for a specified time that you decide what is the specified time. All right. So this is what the debouncing as a whole. Now, to implement this debouncing in React, we will be creating a hook, and I'm going to explain the code in detail. But before that, so far, look into this search component, the search box component. As usual, it has a state called query. Query means whatever you're typing inside the search box, whatever the value that you type inside the search box, that value set inside this query variable. And you update the value every time somebody type on this input type text box using something called onChange, right? This is change event. And using the set query updater function, whatever the value there inside the input box, you set as a query and your state value gets updated. You have an use effect. We all know what it is. It has a dependency called the same query. So it means that whenever the query gets updated, let's make an API call. And here we have simulated an API call like fetch call. I don't have the call in real, just assuming there is an API. So what is happening every time I'm changing something, this query gets changed and this use effect gets executed. I'm seeing this API call with this query every keystroke. Now my intention would be I limit that. I don't make this call. I don't make this one executed for a specified time delay. For that purpose, I have now a hook call useDebounce. This takes two parameters, very important. One is a value, which basically influence the change of the query. Basically, that's the value. And there is a delay that I specify. Here, I have put a default delay of 500 milliseconds. You can put the delay, whatever the delay that you want. Now, if a delay is passed from outside, this will be overridden. This 500 millisecond will be overridden. If it is not passed from outside, it will take the 500 millisecond. But best part over here is this guy. This is the heart of debouncing. It's called set timeout. What does set timeout do? Set timeout deferred calling a function for a specified duration that you provide. So here, set timeout will defer running this function for this amount of delay that you have given. Now, what is this function doing? This function is setting something called debounce value. That's exactly with the value that I have passed to this use debounce. And this set debounce value seems to be a state. So it means that if I do set debounce value over here, it is nothing but setting this particular value, which I am ultimately returning from here. Okay. So it means that even if the value comes over here, the return value from here is happening only after the delay that I am specifying. Okay. So I am actually giving you an updated value back only after a particular delay. That's all this use debounce is doing. Once this delay expires, then I am again giving you the updated value. Until the delay expires, I am not giving you the updated value, because until this delay happening, this particular function is never going to get called. If this function is never going to get called, this debounce value won't be set with a new value and you won't get a new value. As simple as that. Also, please notice in this use effect, I have a cleanup method called clear timeout. Whenever you are using something called set timeout or set interval, you have to ensure that you clearing them as well. Okay. Now use debounce is what I got. Now how can I use it in my search box? Let's see that. So first thing first, let's import use debounce. I have imported use debounce. Call is debounce over here, pass the query, and I'm passing a new delay. Now, if it takes this query is again what? Whatever I'm putting inside the input box. So every time I put something like I put T, I put TA, I put TAP, every time I do that, it goes to use debounce as a value. And there is a delay given. Till the delay is there, it is not going to get set with any of the value that you're passing here. Not with T, not with TA, not with TAP. As it is not getting set with any new value, the value that you get from here is always the old value. Now, once this is get expired, that point in time, whatever the value you passed with that value, this debounced value will be reset and it is returned. Okay. So that value come over here. And now everywhere that we used query, instead of that, let's use debounce query. See, so that's all the code is, right? So now instead of query, I'm using a debounced query, which is a result that was created out of the query itself. But after a delay, whatever the accumulated query I got, I am returning only that. And so the output of this was also changed. Before, for each keystroke, I used to get that I'm making an API call. Now I won't get that. I'll get it only after 600 millisecond since I last typed. So if I type A, see, I'm not getting anything on the right side. Now I'll get a 600 millisecond pause. Yes, I got it. Again, E. Now 600 millisecond. See, now difference. First, it has taken where I stopped all the A's. Then again, where I stopped, A. That's what you have, right? So instead of making an API call, how many A's are there? Probably 8 A's and 4 E's. Instead of making 12 calls over here, I'm making just one call. That's a huge performance boon. If I keep typing things also, see, I'll make just one API call over here. But before, without that, I used to make API call for each of the characters. That's a huge performance boon, don't you think? So this is what debounce does for us, guys. So that's another technique. The last one is about throttling. Last one means it's part one's last one. Okay, part two, we have a lot more to cover. So in the part one, we're going to talk about throttling. First, let's see the demo. So I have a bunch of items on this UI. And again, look into the right side console.log. What I'm going to do now, I'm start scrolling this one, and this is going to show the scroll position. That's not very important. But in the right side, if you see, how often I'm making some DOM manipulation. Okay, I'm scrolling very slowly. You see, I'm scrolling very slowly, showing actually the scroll position over here 4, 5. But this one, almost 28 times is got re-rendered. Almost 28 times I made a DOM manipulation. Now see, it is going to increase. And very slowly, I'm scrolling. It's increasing. As the scroll Y position is increasing, I'm seeing this guy also getting increasing. Now imagine if you are doing certain painting, you're doing certain DOM manipulation, calculation, and every scroll movement, if you are doing it, minute movement of your scroll position, and if the DOM computation manipulation is something which is a bit heavier, this is not a good thing to do. That's why throttling come into picture. So what is throttling? Debouncing, where we can defer a particular function execution or the value generation for a certain period of time. We can delay it. The throttling is little bit different. In throttling, we say that within a specified span of time, I want certain things to happen at most once. Once the span is over, time span is over, again I can make it happen. That's a very big difference between debouncing and throttling. However, many gets confused. Let me just reiterate again for everyone's sake. Debouncing is delaying an execution of a function or getting a value out of something for a specified duration. So for that duration, a particular execution, particular operation is not going to repeat or take place. However, for throttling, for a particular duration, an operation is going to take place, but it is going to take place at most once. That's the difference. Now here also, we'll be using another hook called useThrottle, and the logic is pretty simple over here as well. What we do, we get that value that we want to throttle. Throttle means this particular value is going to change at most once within this particular time frame. If I pass a bigger time frame from outside, of course, it will take that. What we want to track over here, when this value was last changed. Okay, so we track it with last executed, something called which is called date.now, when it got last changed. And here we are computing that right now, whatever the time is, which is right now, and when it was last changed, the difference between these two, whether it is greater than equals to the delay that I have specified. Imagine if the last change happened on, say, 10 o'clock, and the next change is happening at 10:15. That means there is a gap of 15 minutes in this computation. Now, if I have given a delay of 20 minutes, this 15 minutes has not crossed the 20 minutes delay. So the function call is not going to happen. The new value generation is not going to happen. If this delay is say 10 minutes, but this difference is coming 15 minutes, that means I have already crossed my 10 minutes delay. So I'm allowing the recomputation of this value or the function call again. That's all, guys, about throttling. This is the core logic of throttling, nothing more than that. So it means that if a value get passed, I'm actually throttling that value for this duration. Once the duration is passed, I am allowing it to set a new value, and the new value, the throttle value, is what returning from here. This is what the use throttle hook is. Very, very simple JavaScript logic, basically. Now, to make it work, pretty simple. I have to first import use throttle over here, and then instead of having this scroll y value, which I'm showing over here, right? Let's do one thing. Let's use the use throttle, pass the scroll y over here, and pass this a big time, a large time, maybe 3 seconds, right? And this throttle y value instead of scroll y will be using over here. Now let us go to the UI, refresh this, refresh this. Now I'm going to scroll down slowly again. See, I'll start scrolling. I'm scrolling. Okay, I got after 3 seconds. See, it is not coming on my every scroll. Look at the time. I'm scrolling. Look at the scroll, and the thing coming at the right side is much, much reduced right now. Correct? So for every scroll, it is not coming. It is coming only after every 3 seconds. It is happening only once. So my DOM manipulation has reduced a lot. So as promised, we have covered Memoization, derived state, debounce, and throttle. We also spoke about re-rendering and the problem due to that. In the next session, the part 2, we are going to cover the splitting components methodology, virtualization. We're going to talk about the context optimization and also about the React compiler. However, you know that none of our session gets over without a task, right? This session, even though it's a part 1, has its task. Let's take a look into that. Okay, so these are the tasks of your part 1. Fix the broken memoization, take a look into this particular code, and the task is to make sure the child renders only once even after repeatedly clicking on increment. I have showed this already, right? So you can fix it easily. Then improve the derived state anti-pattern. I have a filtered thing and I am just doing this state changes based on something. So you know that I'm not giving you hint. And then build a small dashboard, basically a search bar with debounce, a scroll tracker with throttle. I have showed it, and then the user list with a 10K or more, filtered by search, no derived state with performance optimization, all the techniques that I have showed. Using that, just do this. Very simple. Once you do this task, I'm sure that this learning is going to go inside your brain and you are never going to forget it. All the code will be inside day 11 folder. Come to performance patterns, come to the SRC performance folder, and then you have memoization, debouncing, re-rendering, derived state, throttling, all this, whatever examples I've covered, everything over here. You know how to grab it. You have to go to github.com/tapascript. Please follow this because I keep sharing a lot of awesome repositories over here. And then you can go to 15 days of React design patterns. Once this video is published, you will see day 11 and all this code that I've showed over here will be there. Also join Tapascript Discord where you can talk to other developers and we also can talk sometime and discuss things. Okay guys, stay tuned for part 2 and show your love. Please subscribe to Tapascript. Spread the words about the thing that I'm doing. That will be great help. Thank you. Take care. Hey, hello everyone. Welcome back to the part 2 of React Performance Mastery. If you like the part 1 where we spoke a lot about re-rendering, memoizations and all the things around it, part 2 is going to be a lot advanced. Though it's advanced, but you don't have to really worry if you are just a beginner to React. We are going to go through each of the use cases, problem with a lot of examples and easy to understand language so that you get the entire crux of it and will be able to utilize and use all these things that we'll be discussing in this video in your day-to-day application. Excited? Yes, I am also very excited. If you're coming to part 2 directly, one request would be first finish the part 1 and then finish the task and then come to part 2. If you want to learn something deep, if you want to learn something well, there is no shortcut to it. Take some time, give yourself some time, and that's how you learn things better and you learn things one for all. Let's check out what's there in part 2. We have already learned about memoization, derived state, debounce, throttling, etc. In part 2, we are going to learn about how splitting components logically can save a lot of time and can boost the performance. What is virtualization mean? Where to use it? What are the benefits and how we can do and how we can gain on performance because of using this technique. We're going to talk about context optimization. What is context? We know about React context, but how can we optimize it? So there are certain rules and technique. We're going to talk about them. We're going to talk about React compiler. And apart from these four things, I'm also going to talk about a few great practices that you can adopt while programming in React so that the performance concern is taken care from the first line of the code that you'll be writing for your project. And as usual, at the end, I will give you certain tasks and assignments that I always encourage you to do, because once you do those tasks and assignments after taking the session, your learning is going to be solidified and you are not going to forget the things that you're learning out of this. You are spending some time, right, out of your life. Let it be of a great use. React 19 introduced something called React compiler, which automatically memoizes components, stabilizes the function, references, and prevents unnecessary rendering without requiring any manual effort from developer in writing useMemo or useCallback. In part 1, we have learned about React.memo, useMemo, useCallback, all these utilities. Only purpose of those utilities were that they save you from unnecessary rendering. Until unless a dependency changes for a component, your component is never going to re-render, never going to execute a function multiple times, never going to recalculate certain values. But for all those things, we had to provide React.memo, useMemo, useCallback, all these things with our hand by code, right? But now what we are saying, as React 19 got React compiler in it, we really don't have to write React.memo, useMemo, useCallback, all these things. This is huge, don't you think? It will reduce a lot of code, lot of boilerplate, and a dozens of accidental performance issue. In the part 1, I emphasized about one fact. useMemo, useCallback are great things, but sometimes we overuse them. We kill the code. And now what React is promising, if you use React compiler, you don't have to use those things by yourself. That's great. Now, if we draw a comparison before React 19 and after React compiler came into picture, before React 19, developer had to manually optimize things using useMemo, useCallback, React.memo, right? You remember we spoke about it, that inline objects and the functions can break memoization. That's the reason we were using useCallback and all this stuff. And the other problem was with every render, the values were getting recreated. So if that value was created out of a heavy computation, it was too much to take care for a component. Now, after React compiler came into picture, the best thing that happened, component outputs get memoized automatically behind the scene. Functions get stabilized automatically behind the scenes. You as the developer write less code and React optimizes more. So what does it mean to you? I'm sure you recognize this code, isn't it? I'm using the useMemo hook, and consider, just assume that there is a heavy operation happening over here. Until unless the value of amount changes, I don't want this amount multiplied by 2 to be recalculated. So I'm caching the result. As long as the input to this is remaining same, I'm not going to recompute it. I was doing it because I assume that multiplying by 2 of this particular amount is a heavy operation, just for the example sake. So I don't want to recompute this again and again as long as the value of the amount remains same. Now this is the old way. Let's write it. This is old way. Now what will be the new way if you use React compiler? How will you refactor this code? That's all. That's all you're going to do. There is no use memo at all. You have the amount, you multiply by 2, and you assign to a total variable as you were doing before. You remember, as you notice, I'm not using useMemo. I'm not defining what is the dependency of the useMemo. I'm not telling React anymore when to cache, when to recalculate the thing. React will take care of the things at the background. For me, I don't have to really do anything for this. Configuring React compiler on your React 19 or 19 plus React codebase is pretty straightforward. The only thing you need is to install this dev dependency. You have to install babel-plugin-react compiler. That's all. That's the only thing you need. As I'm using yarn, I'm installing it using yarn add command. Minus capital D stands for the dev dependencies. If I install this, after a successful installation, I will find it over here in my package.json file. And then I have to do one simple configuration in my configuration file. That configuration depends on what kind of project environment you are running. I am running this React application in a Vite-based environment. You can see vite.config.js file over here. If you are running on Vite-based environment, there is one kind of configuration. If you're running it on a Babel-based environment, one kind of configuration. If you're running on a Next.js or React Router DOM, for everything, there are different kind of configurations. Each of the configuration steps are very well documented on React website, React documentation. You can take a look. I have also provided the direct link to that in the description of this video. Now, if I take a look into what kind of configuration I need for Vite-based project, it's pretty simple. You remember you just now installed Babel plugin React compiler. So the vite.config.js file has given a definition of that same plugin over here. Originally, you will find your vite.config.js file like this. There won't be any argument passed to this React. Now, what I have done is just passing this particular argument that this is a Babel plugin and the plugin name is babel-plugin-react-compiler, the same thing that what we have installed. That's all you need to enable React compiler on your React 19 or React 19 Plus project. Now, what does it mean to us? We have done all this thing. How do we know even that this is working? For that, let me first run the server locally. So it's running on localhost 5173. Let me go to browser. Don't worry whatever is shown over here for a moment. But if you open up your DevTools, if you have installed React DevTools extension for Chrome, Firefox, Edge, whatever browser, whatever your favorite browser is, just install that extension, React Developer Tools. In that, there will be something called components. If you come to components, you will see that your entire component hierarchy having a tag called memo. You see that beside everything is called memo. This means that the React compiler is now activated on your entire component tree and each of your components are auto memoized. You have not done any useMemo, you have not done any use callback by yourself. This is auto memoized. Okay, so this is how you can figure it out. Now you don't have to use useMemo, you don't have to use react.memo, you don't have to use callback. Your entire application is memoized. But sometime what happens, you might want to opt out from memoizing your component automatically by React compiler. On that case, you can use this directive in your component. Inside your component, you define a component using function, right? Functional component function, then the component name. Inside that, you can use this directive called useMemo. If you use that, then this particular component will temporarily be opted out from the optimization of React compiler. Now, when you should be doing this, if you find that there is a problem with this component using along with the React compiler, only in that case you will be opting out. But in most of the cases, the recommendation is if you're on React 19 and above, don't use this one. Use and activate for the entire project. See if you're facing any issue, then use this particular directive, isolate this component out of your React compiler perspective, fix the issue, and then remove the directive. I hope that makes sense to you. Now, having said that, if you want to understand or take a deep dive of how React compiler works internally, in general, if you are from computer science and engineering background, you must have learned about compiler. You must have understood compiler in your academic years. Now, how the phases of compiler are related to React compiler and how React compiler take your component code, what it does, what kind of translation happen internally so that it can improve this performance. If you want to get deeper into it, I have created a video for you already. So please take a look into that video. Also, I have written a complete guide and published on freeCodeCamp some time back. You can take a look into that resource as well. I have given a link to both of them in the description of this video so that you find it handy and you can learn from it. So that's about React compiler, which can really make your performance boosted for your application, provided you're on React 19 or above. Last thing, React compiler best used with React 19. It can still work with React 17 and 18. In case you're still in React 17 and 18 and you want to utilize React compiler with it. Here is something simple and realistic for you. React compiler is not a magic. While React compiler gives a lot of things automatically help you writing lesser code, but you still need to optimize a few things. You still need to know how to optimize a large list in your application. You still need to know how to optimize context value. You still need to know how to do component splitting correctly. You need to know how to do lazy loading. You need to take care of something called virtualization. You need to know about what suspense means. You need to know about the concurrency and the transitions. All these things come together along with the optimization of React compiler to give you the best thing about performance. And believe me, there is nothing that you have to do extra. There is nothing that you have to do special. You just need to follow certain good practices, standard practices when you are thinking about coding in React, when you have a use case and you want to translate that into your component before you start writing your first line of code for the component, please take a pause. Think about the use case that you have in hand. For example, do you have a long list of items to render? All the data came from the server to the browser and you have to tackle this large list. You have to do certain lazy loading when you have to do certain kind of transitions. All this thing is what you need to think prior before you start writing your component. So in the next section, I'm going to introduce to you about code splitting and lazy loading. Big application means big bundles. Big bundles means one application you have written the code, you have to build that application so that you create certain bundles, certain artifacts that you deploy on a server. And then on a public IP, your customer can access that deployed artifacts. That's your application. So when application gets bigger, the bundles get bigger. And once bundles get bigger, wherever it is deployed to, from that place, it has to be downloaded on your client's browser. Now, depending on the network, latency, and everything, the download might really take certain amount of time. So it means your application may get slow startup. Lazy loading allows you to load only what is needed and when it is needed. It improves time to interactive. That means that when user click on something, the interaction point, the perceived usability of that element will be much faster. Reduced bundle size, and as I was saying, because of these two, perceived performance increases. Now, let us take some example to understand how lazy loading works. With lazy loading, without lazy loading, what is the experience that our end user gets for an application. All right, let's talk about two components. One is called light.jsx, another called heavy.jsx. What light.jsx is doing, a very simple React component, right? It has a simple console.log, you can ignore it. But what it returns a div, which is having some kind of style, and then it has a h2, it has a paragraph. A presentational component, which we sometimes call as a dumb component also, right? It's a component that's name is light. It's a lightweight component. Along with that, we have another component called heavy component. Okay, heavyweight component. What does it do? Let's see. The heavy component does a heavy computation. It generates some big data, maybe a array of this many elements, as the operation is heavy, we are using useMemo. Why we are using useMemo? If you're coming from the part one, you know why we are using it. So we get the data. After getting the data, we are rendering the data's length and then certain textual elements. That's what we are rendering over here. So this is what the heavy component is doing. Now let's take a look into a component called non-lazy loader. So this is my demo about a component hierarchy where lazy loading is not used. I have imported both light and heavy. In the non-lazy loader, I'm using this light. As you can see, there are of course few textual information, and then I have a button. Whenever I click on this button, I toggle a state called show hide, like this. So whenever show is true, only in that case I am showing this heavy component. So it means that if I now render this non-lazy loader.jsx from my app.jsx file, I will see this bunch of text. I will see a bunch of text coming from light. I will see a button. If I click on that button first time, I will see heavy. If I click on it again, I will hide the heavy. That's what this particular component is doing. But there are a lot of story happening in the background. Let me first open up the application on browser. Let us first see what is happening. Yes, non-lazy demo, of course, a bunch of text. This is coming from the light component, and here is a toggle. If I click on it, it toggled, and I saw this one is getting rendered. If I click on it, it will be hidden. Show, hide, all great. Now let's go to the developer tool using F12. And let's go to the network tab for a moment. Let me reduce it little bit so that I can capture everything. And now I have this disable cache mode. That means nothing is cached. and I want to throttle this to say slow 4G. Okay. Now what I'll be doing, I'll be just refreshing this one, but before that I'll select all as a filter. Okay, so that everything gets captured, and let's refresh this one. So you're saying things are coming. It will be slower because I'm running on slow 4G. Light is taking some time. It took around 2.52 millisecond. Heavy took around 2.57 millisecond. And then after light and heavy both got downloaded, I am getting this entire UI getting rendered. Heavy is something where heavy computation is happening. Okay, I am using React Memo, but React Memo will be impacted only from the second time. First time when it is rendering, the calculation has to happen even if the use memo is there, right? On the first render. So on the first render, I am blocking the rendering of this entire component until I downloaded light and heavy completely. But have you noticed this heavy, the output of the heavy component, the rendering part of the heavy component I need in my application only when somebody click on this show heavy. Then only I'm showing the rendering part of the heavy component. Unless somebody click on this show heavy, I don't need this heavy component on my UI at all. Then why am I downloading the content, so much thing from this heavy.jsx on the browser? Why am I putting this unnecessary load? Imagine somebody is in a slow 4G network, that person is going to see white screen, still nothing is there. See, this heavy is pending, light is pending. Now once heavy came up, still it is processing, now it got it. So this is completely unnecessary, right? This is where lazy loading can come into picture. So as you can guess correctly now, with lazy loading, I can now lazily load this heavy component because the rendering of this heavy component is not required at the first shot of rendering of this entire component. The rendering of the heavy component is required only when somebody click on this show heavy. Then only I can go selectively fetch the heavy component, load that heavy component, and then render that heavy component. That reduces a lot of rendering time on the first load and then improve the user experience because I can now additionally do like a loading state when somebody first time click on this show heavy while I am downloading this particular component lazily and then attaching to my component hierarchy. Till then I can show certain kind of loading indicator. I can fall back to a loading indicator till the component is completely ready for me. That's where I'll be using something called lazy loading along with suspense. Now can we see instead of non-lazy loader.jsx or lazy loader.jsx? So in non-lazy loader.jsx we had imported light and heavy directly. But now I know heavy is something that is coming only when user interact with the link. It doesn't need to be there. It doesn't need to be downloaded at the first shot. So I'm using something called react.lazy. This comes from React itself. You can also do import lazy from React or you can write react.lazy directly. Now here you pass a function. The return of the function should be an import statement where you pass what you want to lazily import, the path to that. So here I'm saying I have a component file called heavy. Please import that particular component dynamically. And as you're importing this component dynamically, I'm passing that to React's lazy so that it takes care of its lazy loading. And it gives me back this component, which I can now place conditionally somewhere where I want this particular component output to be lazily rendered. So far with me. Rest of the pieces are exactly same. Just like before I have a state called show and hide for showing and hide. Just like before I have this H1, I have this P, just like before I have this light. But I have now introduced something super exciting, something called suspense. What does it do? Suspense come up with something called a fallback and it expect certain thing to be rendered asynchronously. It means whenever this show is true, I am going to show this heavy, isn't it? That's my condition. This heavy was not imported like light, not statically imported. It is dynamically imported along with lazy. Now to render that, you need something called a suspense along with a fallback saying that till the point this content of heavy gets downloaded and fully get baked and rendered on your browser, show something in the meantime. So it means when someone click on this button, set the state of show as true, React will start importing this heavy, downloading the content of it on the browser, baking it and rendering it. Till that point in time, Suspense will show this particular div saying that loading heavy component. And once this guy is ready to show, ready to render, this fallback will go over and we will see the content of heavy. What are we achieving by doing this? Of course, the first thing first, When this component, lazy loader component, gets rendered, it doesn't render heavy. It just render H1, P, and light. That means I'm not downloading the heavy component. I'm not downloading the content of the heavy component. I'm not doing this extra rendering. When someone click on this button, being reactive, then only I am downloading the heavy component. Then only I am importing the heavy component, downloading the content of the heavy component, rendering the heavy component. Till that time, I am showing a fallback as well. This is the change. Can you see the output of this? So before I show the output of that, let's take a look into one more thing. When I'm refreshing that, just take a look that both light and heavy is getting downloaded well before I click on the link in my previous non-lazy version, correct? Both light and heavy is now downloaded. Now I'll go ahead, instead of non-lazy, I will import the lazy version of it and I'll use the lazy loader part of it. Okay, now let me go back to the UI. I'll clean it up. I'll refresh it. Now see the magic. See things over here. Okay, getting downloaded. Light is getting downloaded. After light only, I see this UI got downloaded. I don't see heavy here at all. I used to see heavy here along with light in my previous example because light and heavy both were statically imported. Both were getting loaded when this particular component was getting rendered. But now, as heavy is dynamically imported, and dynamically rendered based on this condition of clicking on the show heavy, until unless I click on show heavy, I don't find heavy at all. And that's the reason this particular UI in this time, even with slow 4G, disable cache came up much faster because the heavy computation was not getting done in the background. Now what I'm going to do, I'm going to clear this up just to show you that when I click on this show heavy, that time I'll be able to see that heavy.jsx coming over here. You want to see that? I'm clicking on show heavy right now. You see heavy.jsx. Now you saw heavy.jsx and you are also seeing the rendered part of heavy.jsx. Now if this heavy.jsx is making an asynchronous API call, getting the data, doing a lot of computation on this, till this heavy.jsx is getting rendered completely attached to the component tree, you would have seen that fallback. As it is very much in memory and a very small component, you are not seeing that fallback message is happening very fast. But you got the point, right? Without lazy, you were downloading everything. There is no separation in terms of performance. What is heavy? What can I download dynamically, lazily? Now with lazy and suspense, you have that entire content. I hope it was helpful. Now let's talk about another technique called component isolation. Now this is a good practice part than a pure pattern because the pattern of this we have covered in part 1 already, which is called memoization, but a good practice that I want to highlight. What we know React re-renders children automatically when parents re-render. But with proper isolation, we can prevent this. Here is an example, which is a bad example. What do you see over here? There is a dashboard component which take two props. One is user, another is statistics. It uses three child component, one called user card, another called revenue, another called visitors. The user card uses a prop called users, which uses this particular value. Revenue has a prop called stats, which uses this stats value. Visitors doesn't have any prop. Now in this situation, if the value of the stats changes, this dashboard re-renders all the children re-renders, even the one that doesn't depend on the stats directly, right? User card is going to get re-rendered, visitors also going to get re-rendered. Now how can I rewrite this example little bit better way to save from this re-rendering? Let's see a good example for this. The good example for this would be this isolated dashboard. Here also we have imported this revenue, user card, visitors, but as you see, I have used memo from React, pass this component all together, the user card and the revenue, which are props dependent, and got a memoized user card, memoized revenue. And now I'm using the memoized user card, memoized revenue. Because of this isolation, what happened? If the stats changes, now only this guy gets re-rendered. This is never going to re-rendered because user, the input to this aim user card, which is a memoized version of user card, is never changing. So it is memoized, it is cached, it is not going to re-render. So we have learned this technique of memoization in the part 1. I'm just showing certain good practice of how you can isolate components with memo so that it creates certain amount of render boundaries, and that's a pure win. I hope you find this useful as well. By the way, are you finding it helpful? If you find this helpful, especially the part 1, part 2, you should look into my full-fledged course called React Design Patterns, 15 days of React Design Patterns, which is available for absolutely free, taking you through all the important design patterns that you must know in React and apply them on my YouTube channel. The link to that is in the description of this video. All right, so the next one, we are going to talk about context optimization. What is context? We know React context is pretty powerful, but can cause massive re-render because it forms a chain, right? You create a context to provider, you provide the value. Now, wherever you want to use the context in your component hierarchy, you can take the value out and you use. Now, something somewhere change can't re-render your entire component hierarchy, which providers have wrapped. So you have to really be mindful of how you can optimize your context. Let's see one example for that. Can you tell me whether this is good or bad? Let me explain this to you. I have created a provider, say user context provider. Now this is coming from the user context and I am giving value, means I'm providing value. One is the user data, another the theme information of my application. And what it is wrapping? It is wrapping my entire application. What do you think? It is good or bad? I would consider this as bad example. Why? Because it is using one big fat context. Imagine if theme changes, all the components that is consuming user also re-render. Now, if the user changes, all the component that is consuming theme is going to get re-rendered. Now, if these two values are something which is partially be used inside your application component hierarchy, you won't be passing things like that. So what is the good practice? The good practice would be splitting the context. Now the same example, you can consider writing in this way. Like you split them as user provider, you split them as theme provider, you wrap the part of your application tree where you want to provide the user information, you wrap the portion of your component tree where you want to provide the theme provider, right? It not necessarily it has to wrap the application. It can go inside the application and can wrap a particular portion of the component tree where you want to provide the user provider. Now, the first level of optimization that you can do is first split the context. Like I have splitted the context with user provider and theme provider separately. Here I was passing the user value and theme value one big fat context provider. Don't do that. First is split. Second thing, be mindful whether user provider, theme provider need to wrap the entire application, or can I now go one more level down, identify what is that portion of my component tree that only require my user provider or my auth provider or my department provider, whatever it is, wrap only that portion. Theme provider might be something that should wrap the entire application. Okay, great. But user provider may be something which should not wrap the entire application, maybe the part of the application. So this is another optimization technique that you have to make sure that you keep in mind, because context is something that can leak a lot of performance issues in your application if you're not mindful about splitting them and use them contextual. Have you seen some UI that renders like say 100,000 list elements, and once you start scrolling them you feel like very sluggish, is jank? Virtualization is a technique that solves exactly that by rendering only what's visible on the screen. Okay, and then again when you scroll it further you can load the next set of item. Again you scroll it, you can load next set of item. So when you do virtual scroll, when you do pagination, on those cases virtualization is a thing that you must keep in mind. See, the thing is like what you show to the user, that's visible to your user. Why do you want to unnecessarily bring things on your browser, load your browser memory that are not visible to user? Once you want to make certain items visible to user, again bring that to your browser, occupy your browser memory and make it visible, make it rendered for your user. So that's what virtualization solves, is another performance optimization technique through which you render only what's visible on your screen. Let's learn by example. All right, I have this demo for you. So this has two mode. One is virtualization mode, one is non-virtualization mode. Right now, I am running on non-virtualization mode. I have a huge list of array which I have rendered in the non-virtualization mode. It means that I am rendering possible everything. Though if I scroll down and I see like I'm rendering only 7, and if I scroll down using this scroll, I'll be rendering more elements again and again. I'll make it little smaller so that everything come on the view. Yeah. Now using this scroll, I will try to scroll it. I find it really sluggish. You see this? Every time I try to scroll, it is really, really sluggish. It is really, really slow. Now, one thing that you can see over here, once you go up also it is slow. If I just right click, even my right click is also taking some time. I right clicked already. Still I'm not getting, now I'm getting inspect. Okay, and click on inspect. Okay, and then on the inspect bar, you come over here. Inside this div, if I just expand, see the number of divs that I have. Each of the div is nothing but each row, right? So even after this many div, this div, this is the 7th one, this is the 8th one, which is not there in my visible area, but still I have loaded on my DOM. It's an extra thing. I don't need it. I don't need it. I don't have to go to 9,999 element because that's not visible, guys. So that's one problem. Second problem, if I go to the performance tab, this is the performance tab. I'm sure that many of you are not using. If you're not using, you must learn about it. And if you want a video from me, how to use performance tab, how to use React Dev Tools, comment. Let me know. I'm going to do that. All right. So what am I going to do? I'm going to refresh this and then I'm going to run this recorder. Let's see. I'm going to refresh this and I'm going to run this recorder. The recorder is running. In the meantime, it refreshes. It brings my UI back stable. I'll stop this. So it will load the trace in a moment and you'll see something. It's loading the trace. It will take some time. It's loading now. It is processing the trace now. Now it gave me some result. Let's analyze this result. What I want you to do, I want you to note down these two things, these two numbers. How much time it took for scripting and how much time it took for rendering. For scripting, it is almost 3 seconds, 3275 millisecond, and for rendering 2.3 seconds, 2361 milliseconds. Total, it taken about 8 seconds for rendering. 8 seconds for rendering. I'm probably rendering 10,000 array elements in different ways, right? Without any virtualization. Now, let's close everything. Let's click on the virtual mode. Use the virtual list. This is my virtual list. It is actually showing a lot of elements, but because of my style, it is a little bit unseen for you. But this is showing. Great part, I can scroll it pretty easily. I can scroll it very easily. Very, very easily I can scroll it. There is no sluggishness at all. There are some styling issues, that's fine, but I can scroll it. So when I inspect this, inside this, only a few, 1, 2, 3, 4, 5, 6, 7, 8, 10. That's it. Rest of the div not even created on my DOM. That's the power of virtualization. If I come down little bit with the scroll, I probably will be adding next 10. If I scroll down little bit more, I'll be adding next 10. I will go 10 by 10 by 10 using the virtualization technique. So that means my initial load is pretty fast. I'm not loading all unnecessary things that are not visible. Here, I'm showing probably first 6 or 7, but I'm loading 10. It's still okay. I'm loading aggressively 3 more. But previously, I was loading all 10,000 together, which was a huge kill to my performance. Okay, so that's the first advantage of virtualization. Now, next thing, I am going to do the same thing with the performance thing. But for that, I have to refresh this application. And if I refresh this application, the default mode will go to non-virtual list, right? So I'll tweak my application little bit. I'll go to virtualization demo. Over here, my default mode is non-virtual. I'll change that to virtual. This one line of code change. Now, if I refresh also, by default, it will be virtual. You see how fast it is. And you see this red also got changed to green. I have disabled the cache and everything. It is how fast you can actually imagine. But let us do the same thing. Can you see scripting? It reduced from 8 seconds to like 2 seconds. It has reduced drastically. It has gone like 1/4 or below just because I have now opted for virtualization. Let's take a look into the code very quickly. So this is my virtualization demo. I have had a mode based on the link that you click, right? Non-virtual versus virtual. I basically render two different components. One is the virtual list with all the user data, and that is called non-virtual list. Non-virtual list is a as usual thing. It's a ULLI element where I take all these users, loop through it using map and show all the information of the user. But for the virtual list, I'm using a library called React window that helps us in getting virtualization in React. From that, I use the component called list, which is given by React-window, to which I pass this data and I pass few configuration value, and that's it. It takes care of the virtualization, right? So whenever you have to show the long list of data, always ensure that you opt for virtual list. You opt for virtualization. You have seen the performance gain versus performance degradation with the example that I've showed to you. I hope it was helpful to you. All this source code, whatever I have used so far, is on my GitHub called github.com/tapascript. You can follow this organization if you find it helpful. Under repositories, you will find 15 days of React design patterns. And inside this, You will find all this code inside day 11 because this is when we are talking about the performance patterns. If you like my work, don't forget to start this repository as well. The next technique is about the concurrent rendering using transitions. Okay. React 18 introduced something called concurrency in React to keep the UI responsive. The problem that you usually face when you type into a search box like this that filters among thousands of elements, 10,000 elements, 100,000 elements, your UI freezes, your keystrokes lag, your browser's main thread blocks. That's where React came up with a solution called a hook called useTransition. Now we are going to see how we can use the hook useTransition and where exactly it is useful. You can import the hook useTransition from React. The hook useTransition give you two things. One is a function called startTransition and a state called isPending. The function startTransition tells React this particular update is not urgent. Keep the UI responsive while you are doing everything that is defined inside this function. For example, I have this text box. Now this text box has two jobs. One, if I type something, for example, E9, it has to show E9 and it has another job to pass this E9 to this below list so that this list get filtered and I see the updated result over here. Now, if you think about the user experience, you don't want user to feel lagged when user is typing each of the character over here. It is okay if the processing of this filter list takes certain time because you might have to go to server, an API call, you have to process certain algorithm, you have to come back and you have to show the result. So this is okay. You can probably show a loading indicator or something to manage it. But what if you type S and then it's a huge lag before you type E? That's a bad experience. So now among those two operations, like one is typing, another is filtering, which one you think React should prioritize? Of course, the typing into this box. So that means typing into this box can be a faster operation and a secondary operation, non-urgent operation would be filtering this particular list. Now, as I had explained, what use transition gives us, it gives us a function called start transition using which you can define what is that you can tell React, hey React, take it, little bit relaxedly. Don't really panic for this. Keep the UI responsive while you are doing whatever I have written inside the start transition. And when the start transitions function execution is done, turn the is pending to false so that I understand there is nothing pending from you in the start transition function. Now with the same example, I have two state. One is the text, another is the query. The text is the input text box value which you want to keep updated immediately. That's the reason if you see in the handle change, whenever somebody typing, I'm immediately calling the updater function to update the text. Fantastic. But filtering the list, it depending on something called a query, right? Because if you see this query, this is where my heavy list is getting computed. Okay. I'm passing this query. Now setting this query value, what will be the query value based on which I am now filtering my heavy list is inside the start transition function. So the start transition function is marking this heavy update as non-urgent. Updating query triggers expensive filtering plus rendering, that and all can be marked as non-urgent for me. I hope this is clear to you. So again, if you want to get much more deeper in concurrency, how use transition internally works, I have created a video only for that purpose. You can take a look into that. Again, I have provided the link to that video in the description of this video. It will be helpful, I'm sure. Just like use transition, React gives us one more fantastic hook. It's called use deferred value. Sometimes people confuse between use transition and use deferred value. Let me explain. Both use transition and use deferred value are React hook used for performance optimization by marking certain operation or the updates as low priority. In terms of the demo that I have done for use transition, setting the query value that in turn does the filtering, we marked as low priority item, correct? By setting the text on the input box, it is an usual high priority item. Now, purpose for use deferred value and use transition is same, but how they do it is where it differs. Both leverage React's concurrent feature, but the primary difference is what exactly they control. The use transition hook, what we have seen before, controls the state update function. If you remember in the use transition demo, if I have to open it again, we were controlling the state transition function of set query using the start transition, right? Whatever we write inside the start transition function, that is kind of deferred. That is a low priority item. So here, what we control the state update function itself. But in case of use deferred, if you see the usage of use deferred value, here you control the value that result from the state update. Okay, there you are controlling the function itself. Here you control the value. So what is happening in this case? Almost similar kind of application. The text which is used in the input element, it means that text update on each keystroke must be instant. The deferred text which is computed out of the text and is a deferred value, which means it's a secondary citizen. React is not going to look into it as a high priority. This deferred text is used for filtering my product. So I could have done the same thing using use transition. In that case, inside my start transition, I would have had another state called say query or set query. Set query is what I would have marked as a secondary priority thing. But if I want to do it with the value itself, I can use something called use deferred value. So use deferred value and use transition, sometimes people confuses. There's no confusion. Okay. So this is what the differences are. And another way where you can optimize your performance. Our performance optimization video won't be complete without talking about this. So React uses keys to match the old and new elements, right? We know about the virtual DOM, we probably know about the Fiber framework, and etc. Now the keys are a very important element in React. Now here something is very bad. We have used index as a key. What is bad? Adding or removing item shift indexes. React thinks entries have changed. It breaks the memoization, causes unnecessary DOM recreation. So this is another thing people take lightly. Please don't do it. The right approach, the right way of doing this would be use an ID from your data structure, which is unique, and use that. So this is stable key, what you should be using when you're iterating through a list in React. Stable keys prevent React from destroying and recreating the nodes, helps in better reconciliation. That means it's a faster UI. So this is another thing, another technique that you have to keep in mind. We're almost at the end of the part 2. We have spoke about a lot of optimizations, but it is not complete without talking about some of the tools. We have seen the usage of a few tools in the part 2, but let me talk through a few tools that you should explore. You must explore. One is definitely React developer tools. It has a very, very strong potential, and documentation of React has captured it very well, step by step, how you should be using it. Please go ahead, take a look, explore it, how to install, how to use it. So React developer tools is one thing. Second thing, there is something called React performance tracks. This is something you should be looking into for understanding scheduler, the cascading updates, how components are getting rendered, all the aspects of it. Again, this documentation is very extensive. Take a look into it. And then there is another tool called React Scan, which I use very often to see like what part of my React application is unnecessarily getting re-rendered, catch that guy and try to fix it. So these are some of the tools. I'm sure like it will be very handy for you. As this video and the previous one was very focused on React design patterns around performances, I didn't cover these tools in depth. But if you think that I should be making a video covering the usage of each of these tool, their right use cases in depth, you know what to do. Post a comment, let me know. If there are more ask, it's a great motivation for me to make again. And by the way, if you don't want to miss any of those updates, please follow TapaScript, because that's where I create awesome content, lot of deep content taking a lot of time. I'm sure you're going to love them. So please follow TapaScript. You know that none of my session gets over without the task. In the part 1 of the performance patterns video, I had given you few tasks. Let's skip them. I'm skipping them because I've already explained this to you before. Now, the new tasks are remove unnecessary useMemo and useCallback. So there is a product card where I have useCallback, useMemo. You have to gain performance by removing them. You know what to do. If you have seen this session, what React provides you from React 19 to automatically memoize your component, you know that. So use that. These are the assignments. Remove unnecessary memoization, explain why React compiler handles these cases, identify when memoization is still required. And lazy load a country dropdown, build a form with the fields like name, email, and the country dropdown with 250 countries. Assignment, move the country selector into a separate lazy loaded component, show a custom loaded like a spinner, and then measure the initial bundle size with your lazy component versus non-lazy factor of it. And then on the splitting context or the context optimization, let's see how this big context where you have user, theme, cart, local, everything together, how can you break them into different context, maybe user, theme, cart, local, whatever you can think of, and then split it. So these are the new 3 tasks that I have given. You can do it. You can also think of tasks around virtualization, take a bigger list, how to virtualize using React Window or any other solutions or your own solutions. You can actually try that. So this is the task. Please complete. Hey folks, how was it? I hope it was helpful to you. I'm super happy completing part 1 and part 2 of performance patterns. I hope you find it helpful. The list of performance techniques, the good practices, the best way of handling performance, whatever we have discussed, please note them down, take a good look into them and see where you can apply them in your day-to-day life. Before I end, one word of wisdom: don't try to optimize performance of something which is already working great. Performance optimization is required only when you found with the feedback, whether the feedback is yours, feedback is from your QA team, feedback is from your customer, or the possibility where the performance degradation might happen. Then only pick up the technique among all these things that we have learned, which is applicable, and optimize the performance of your application. I wish all this learning stay with you and you become a champion developer tomorrow. If you want to catch up more, please catch up React Design Patterns course, which is for free, available for free on ThapperScript channel. Follow ThapperScript for future content, future updates. You won't be disappointed. Take a great care of yourself. Stay tuned. We'll be coming back again with some great content in the future. Bye bye.